Hello and welcome. This is part 3 of our IPsec VPN demo. In the previous two videos we have configured the IPsec responder router, the WR44. Then we configured the IPsec initiator router on part 2, the WR31. And at the end of part 2 we had a working VPN tunnel, which is great. We love it when things work like they should. But what happens when things go wrong? And that's what this video is going to be about. It's going to be about putting faults on the WR31 router and being able to debug the connection problem and work out why things aren't going exactly as they should do. IPsec VPNs are fairly easy to work out what's going wrong when they don't work, as long as both routers are the same type and they're running the same operating system. You can just go and have a look at the configs of the initiator router and the responder router and make sure everything is the same where it needs to be the same, or transposed where it needs to be transposed, and make sure there's no typos. So even without any debug, you could just go onto the configs and have a look. But say for example you've only got access to one end, what can you do? Or if the routers are of a different type or different operating system, when you're working with cross-vendor VPNs or you've only got access to one side, then it becomes difficult to start just having a look at configurations and making sure everything matches. It's not quite so straightforward. So that's where we have to start looking at the IPsec negotiations and see what's going on in the background. The first thing really that you need to be aware of is that if a VPN negotiation fails between two routers, the initiator is only ever going to get a go away message from the responder. The responder isn't going to say, well, hang on a minute, you're trying SHA-1, I need you to use SHA-256 instead. That doesn't happen. That's a security risk. A VPN is built to be secure. There's no point in a responder router saying, hang on a minute, you're doing this wrong, you need to do this instead. So the initiator has to be configured correctly from the start. If for some reason the VPN negotiation fails, the initiator router is only going to get a message back that says no proposal chosen, which is the best scenario. At worst, it gets nothing back at all because maybe a firewall has blocked the traffic. So if you've only got access to the initiator router, then your VPN debug basically is very, very limited to looking at, do you get an error message back from the responder router that says no proposal chosen, or do you get nothing at all? And then you hand it over to whoever has administrative functions over on the other router. So all we're going to do is use the initiator router for in this lab is to put faults onto the VPN, and then we're going to have a look on the responder router at the debug and work out what has actually happened. Now you're not going to see me put the faults on, but you're going to have a look through the debug on the responder with me, and we'll see if we can pick out the error messages that are there in the logs. For the rest of this lab, we're only going to be using the CLI. I'm sorry, but if you're used to using the GUI interface, then that's no good here. You're going to have to switch to the CLI. We're going to be using Telnet in this case onto the responder. You can get good debug using Telnet or the serial interface on the router, ASY0. Debug isn't directly available in an SSH session, but you can SSH to the router and then run a Telnet session back to the loopback interface on the same router to get access to the Telnet interface, which is where the debug is. So we're on the responder router now, and if we have a look at the SA stat, we can see the VPN is failing to negotiate. Let's have a look at IPsec, so we've got no phase 1 SAs either. Let's have a look at the event log. And we can see here we've got loads of errors. So the latest one, phase 1 session, keys negotiated, so that's phase 1 complete. New phase 2 session, So this is the IPsec negotiation. This side is working as a responder router, and we're sending back a no proposal chosen message, which is all that the other side is going to see. It's going to see no proposal chosen. In fact, I'll show you that. Let me just jump onto the other router, and if I bring this across here, you can see here IC notification, no proposal chosen, RX received. So this side is only ever going to see that no proposal chosen. To get debug, we need to go into IC 0 and we need to enable debug mode. So we need to enable the debug level and then enable it. So we do IC 0 deb level 4 is very high, so we'll set it to 4. IC 0 debug on. If you had multiple VPNs being built into this router, you can look at the IP address up here of the initiator router. If you've got multiple routers building VPNs, you can pick out the one that's failing, and you can do IC 0 this here, IP address filter, and put in tilde and then the IP address, and the tilde means filter in rather than filter out, so we're filtering in traffic from this IP address. We're only debugging one VPN, so we're not going to bother with that. The next thing we need to do is go into the phase 2 configuration, which was eroute 0. So here we've got the VPN with UK WR31 number 1, and in here there's another debug option, and we need to enable this. Debug on IPsec and IKE is disabled by default, so we'll do eroute 0 debug on, and then to get this debug out to a telnet session, we'll do debug T, and this should start scrolling and scrolling and scrolling. Every time the initiator reattempts, you'll get more debug out on screen. So we'll wait for a bit more, and then we'll do debug off, and that stops the debug coming through. If you were connected on a serial interface and you want the debug to go out to ASCII 0, you do debug 0 instead of debug T. So debug T for telnet to start the debug output. And all of this that we see here is a phase 1 and phase 2 negotiation. You can start at the top and work down. I generally tend to find it's easier to start at the bottom, the very latest notifications, and then work up, because what you're looking for is this here where it says no proposal chosen, and this is the responder router sending a no proposal chosen back to the initiator. And we'll keep looking up, we can see another one, notification type no proposal chosen up here, and then we see this, an error message. Okay, eroute 0 local IP outside traffic selector range, unable to locate eroute matching this negotiation. And this is a really common one. People will get subnet configurations incorrect between the two routers. When you see this appear down here, it's just I've got a recurring command set up so that my telnet session doesn't time out and close this window. So ignore that, that's just automatic. So locating eroute matching this negotiation, local IP outside traffic selector range, and then we look a bit further up and we see here where it starts to display subnet information, getting remote subnet details 192.168.101.0, getting local subnet details 192.168.102.0. Checking the diagram, we can see that we've got 100 on one side and we've got 101 on the other side. This is the encryption domain on the WR31. So the debug says getting remote subnet details, remote subnet is 101, so this is 101 here, and then getting local subnet details 102, and looking at the diagram, the local subnet on this side should have been 100. So we can see there that the other side has been configured incorrectly with the incorrect subnet. So if we have a look at the configuration on the WR31, let's have a look. So we got local subnet, remote subnet. It's been configured with 102. So if we do eroute 0 rem IP 192.168.101, sorry, 100.0, verify that with a new config C show. We can see there it's now 100. Back over here to the responder router, SA stat, the VPN is back up. Right, let's try another one. I'll put a different fault on the VPN on the other side and come back over here. SA stat, the VPN's gone down. Okay. Have a look at the event log. We can see here this is where the VPN came up after it was negotiated correctly. VPN up. And again we're back to sending and no proposal chosen. Let's have another look at the debug. Looks to be enough there. Debug off. So we're sending phase 2 notification, no proposal chosen. We come up and we can see here eroute 0 ESP encryption algorithm mismatch. So we know now that it's nothing to do with the subnets, so we keep going up and looking at other details that are shown in the negotiation, and we're looking for the ESP encryption algorithm. Keep coming up, keep coming up. We've got authentication algorithm. Keep going up. We've got mode, it's a UDP tunnel. Keep going up. ESP algorithm. Oh, look at that. We've found it triple des. On this side, it's set to AES. So at this point we'd say to the person with the administration on the initiator router, hang on a minute, we need AES 256, you're trying triple des, please change, and as long as nothing else is incorrect, the VPN should come up. So let's change that back on the initiator. So we'll come over here. In fact, you can see here where I made the change. Look, eroute 0 ESP enc 3DES. So we'll just do, oh, really useful shortcut. You press up yes, to replay through the commands. The only thing is, if you start deleting stuff, you then can't cycle through more stuff on that same command. So here, if I delete the S, the only option to complete is that. But if I start, got the different options for the ESP enc command. Let's check the VPN came up, and we'll try another common one. Now look at this one. This is a really interesting one. If ever you see a bad packet, that should be a clue straight away, because you only really see this in a certain situation. So it's different from a no proposal chosen, because when the negotiations occur, everything seems to match except for something else that doesn't match. So let's have a look at the debug. A bad packet, if you ever think about how packets are constructed and authenticated, a bad packet should give you a clue straight away as what's going on. processing ID payload. ID type 11 is key ID, so that's IC IDs. Decoded ID is WR31UK1. Bit further down, AES256, SHA-256, pre-shared keys. Everything looks okay. Keep coming down. We're using Diffie-Hellman group 5. Transform 1 has all the required attributes, so that says yep, everything's good. Retrieving password, decoding ID type 11 key ID, and there's nothing really obvious, and you'll see it just keeps going on and on and on, and there's really nothing here that's going to give you an idea of what's going on. We can see here it's an aggressive mode negotiation, ID is created, create hash using password 0. Really there's going to be, in this situation, there's going to be nothing that screams at you, this is the problem, but you really have to think about what bad packet means. And a bad packet basically means that the pre-shared key between the two routers that's used to create a hash on the packet doesn't match on both sides. So although everything seems to look okay and it's just not working, if you ever see a bad packet, go straight for the pre-shared key. So on this side, user 10, let's have a look, and we've got this here, which isn't the plain text password, it's the e-password, which means it's obfuscated. User 10, e-password doesn't match. So what we can do here is I can either retype in the plain text password, which I say is not this, you use the password command, or I can retype, or I can just copy over the e-password. So I'm just going to copy over the e-password because it's nice and simple. If I can get my session back, there we go. User 10, e-password, paste that in, and the VPN comes back up. So if you ever see a bad packet error message on the responder, you can go through the debug. It's going to show you what is working, it's going to show you potentially, you know, this is what's happening, but it isn't really going to scream out at you, this is the error, the pre-shared key doesn't match. So that's always a good one to remember. Bad packet, pre-shared key. Right, final one. Let's pop on a different one, which is also quite common. Okay, so I've modified the configuration on the responder router as well as the initiator because I just needed to make a change, so there's something else we're going to see that's fairly common. So I've dropped the VPN and it's trying to renegotiate, and what we're seeing now is a new phase 1 session coming in from here with the responder router on this side. IC negotiation failed, peer, no transform selected, so we're not even completing phase 1 now, so we're not getting through to the phase 2 negotiations where we see the IP addressing and the IDs. So now we need to have a look again at the debug. Let's see what comes up this time. And if you've worked before with IPsec, where it says transform, there's a problem with the transform. This is it basically means there's a problem with the negotiations at phase 1. Something didn't match or something wasn't available. Debug off, and let's have a look down. Preparing for new phase 1. So we're going to work this one from the top down. Preparing for new phase 1. IC role responder, and we're looking here to see what is being sent in from the other side in the negotiation. AES 128, SHA-256, pre-shared keys, Diffie-Hellman group 5, lifetime. Keep scrolling down. We've got more details about what's being negotiated again. AES 128, SHA-256, pre-shared, Diffie-Hellman Group 5. Lifetime, unacceptable key length, minimum 24, max 32. Transform not selected from proposal. So what is going on here? Saying key length 192. Something's going on that doesn't sound right. Key length 128. IPsec 0, the key length that we're expecting is 256. So if you were to see this on your VPN responder and someone's trying to build a VPN into your responder router, and you look at that and go, hang on a minute, according to these logs you say you've configured AES 256, actually you're sending AES 128, so maybe you've configured AES 256 at phase 2 but you're only trying AES 128 at phase 1. Let's come back over here and do IPsec 0, and lo and behold, AES 128. IPsec 0, and then we do key bits 256, and let's see what happens. VPN comes up. That's the end of this lab and the run through of the IPsec debug. Hopefully there's enough there to get you started working with debugging VPN connections. If you've got an initiator router, don't forget you're not going to get any useful debug out of that as far as working out why a negotiation failure is occurring. You need to get onto the responder router and work from there. If you've got one of our WR routers as the responder router, brilliant, loads of debug available. You get very similar debug on Cisco routers. The capabilities of other vendors' equipment is some's good, some's not quite so good. You won't get such a thorough debug output as you see on our router and as you'll see on maybe a Cisco. In that situation, I tend to turn the VPN around and make our equipment a responder and put the other side as an initiator and see if we can work it out that way. If you need any help debugging VPNs on our equipment, drop us an email through to tech.support@digi.com. We're always more than happy to help with IPsec VPNs that are failing negotiations. If it's cross-vendor, then you need to have a support agreement in place before we'll be able to help you with that. But if it's transport to transport or our own kit, then yeah, we're more than happy to get involved in that. I hope you found this useful. That's the end of the IPsec 3-part responder, initiator and debug. Hopefully you've got plenty of information there to get VPNs up and running and have fun building labs and get them running in your live networks. Thanks for watching.